sheet, which you're not going to be given on the Regents. Box 8, continuously. What is the formula? Yep, that's how exactly I remember, A per. If you tell me something is being compounded continuously, I remember that formula right there, A per. Okay? Let's go through what each piece means right now. P, principal, how much did I start out with? Ooh, got him already. Got him already. Read through the problem again. She puts half the money into each account, so how much is she starting with? 10,000, everyone. Ready? 10,000. You are not plugging in for E. E is a number. It's like pi. Take a look at my calculator. E. That's a number. Okay, that's a number. So it's just going to stay E. We don't plug anything in for that. R for rate. Guys, read carefully. The one we're compounding continuously. What's the rate for that one? The one that's compounded continuously. Continuously. That's the one we're on right now. Continuously. 0.8, but I'm not putting 0.8 there. That's a percent. I don't never put percents into the formula. What do you got to do to the 0.8? By doing what? Divided by? All right, go ahead. 0.8 divided by 100. 0.008 times t, the time. So there's continuously. A pert. You'll see it again next Thursday, I bet. And then there's another account that's compounded how? Not continuously, but monthly. Look down below in box 8. You'll see the any other than continuously formula. P times 1 plus R over N to the NT. I don't know. I'm sorry, guys, with all these formulas, but it's a year and a half worth of material now. Okay, principal. Principal. Half the amount, right? 10,000 times 1 plus, what's your rate for the monthly one now? 0.9%, so that's going to be, yep, 0.009 divided by, what did I write what N stood for? Yeah? Compounded per year. Monthly, so it's going to be 12 times a year. NT, 12T. I'm going to take both accounts, add them up. Now the only question is, I don't see that because I need to figure out what that number is inside the parentheses. So I'll walk around making sure we can use our calculators instead of having a staring contest. It's all right. I'll wait for everyone. I got the time today. I'm not going to be confident enough here. Okay, here we go. 6, what choice do we get? Choice 4. Questions there? Okay. Right below it, 19. We are not asking what graph represents x squared plus 2x plus 1. This is part of a bigger equation that represents these graphs. Okay? This is not, I'm not asking you to do this into your y equals screen and figure out because you're not going to find it. This is part of a bigger equation that represents one of these graphs. What do you want? What's it look like you can do to that? Yep, go ahead and do it. Here we go. Help me factor that. Now it's going to get live. 2. Okay, 2 numbers that multiply to what? Okay. Can we stop there? Okay. How do I make them add to 2? Good. X plus 1, X plus 1. Okay, what are the answers then? If those are my factors, what are my answers? Here we go. 2 again. X equals. And X equals. How many times does -1 occur? Twice. That's a double root. We've talked about this already. What's a double root look like on the graph? Just touches it at that point. Just touches it at that point. So knowing that now, which choice am I looking at for this one here? Here we go, 11. What choice am I looking at? Choice 1. Graph what? This equation? It'll look like this. I guess you could do it like that if you wanted to. All right, that's fine. Other questions? Great job, Spencer. Other questions? Okay, going on. Here we go, 24. How many solutions? Look, I'll even admit I have no idea how to solve this. But am I looking for what the answers are? I just want to know how many there are. So is there another way around this other than me trying to solve it, figuring out how many answers there are? No, plug in numbers. Why? Okay, plugging in numbers, what would that do? That's just going to see if they do equal, and then you're going to be like, well, I don't know, maybe there's more. Maybe there's more. All right. What's the other way around this pretty quickly, Lauren? No, you don't want to look at the highest exponent here. That's when everything's equal to 0. You can if you want. Okay. Still wait. There's an easier way here you're not thinking about. Where they are equal. What'd you say, Aiden? Graph it. Graph it. See how many times they do what? Intersect. Let's go. Calculators out. There's another reason I'm doing this problem too, and that's because I want to make sure you know where all these buttons are. So right away, fraction template. Also, I learned my lesson the hard way, 5th period. 1, please make sure you use the subtraction button in the denominator there, not the negative sign. 1 minus x squared. And then now, everyone, hey, what type of button should I use here when I plug in the right side? Okay, before even the absolute. No, before the absolute. Negative, not the subtraction button. You're going to get an error in your calculator. That's the negative sign. So in Y2, negative. All right, now where do I go to the absolute key? Okay, you can go math, scroll over to number, and it's right there. Other ways? Some of you guys can go alpha window, and it's right there. Or the third way I found out today is you can go second catalog, second 0, and just it's alphabetical. You can look up absolute. 3 different ways to get there. Okay, I just want to remind you guys, I unfortunately cannot help you next Thursday searching for these. So we got 3x minus 2. And then make sure you go outside and add in the plus 5. Okay. Yeah, great. It looks great, but I only care about what? How many times they intersect.
This is, oh my gosh, this is so cool.
That's how many solutions they'll have. How many spots of intersection? Should have 1, 2, 3, 4 spots. Okay, I'm going to come around now. Anybody not getting this because I got to help you out? Tell me now. Anybody not getting those graphs out? Because it's probably just a sign thing. We all getting those graphs? All good? Okay. That wasn't too bad, right? Just had to remember to do it. Had to remember when they're equal to each other. All right, we're done with multiple choices today. And we're back to part twos. 2 pointers, 26. Read through it. Yep. That means we'll talk about that in a second. Okay, my first question. Where are those going? I know it's got to go through those on the x-axis. So right now I am plotting 2, 4, and then -2 and -4, because I at least know my graph has to go through those points. But now how's it go otherwise? Right? Where's it going to start? Where's it going to end? How many zeros are there? 4, which means the biggest exponent on this equation has to be 4, right? So it's got to be like x to the 4th. Now I'm going to dig something up from last year. If the highest exponent is even, do you remember how the graph started and ended? Okay, ready? Ready? Here you go. Hold on. Ready? What do you want me to go? X to the? That would be even, so that would help. 8th. Here you go. This is what 8th looks like. Okay, here we go. Let's go x to the 14th. Any even number here. Let's go x to the, let's just go x to the 6th, and then let me put some other stuff here. Minus 5x plus 1. Highest exponent still what? Even. Okay. Anybody seen when the highest exponent's even? It starts and ends the same direction. Not necessarily, it could go down. Here you go. It could go down. Ready? Negative x to the 4th. Here you go. Oh, that's because I didn't put the negative. There we go.
Oh, yeah. You gotta remember to put the negative.
Yeah. It could also go down. As long as what the deal is, as long as that leading the highest exponent is even, it's going to end and start in the same direction. Okay. Anybody remember end behavior? That's what they called it last year. End behavior. So you guys decide. If it's going to start up, it's going to end up. If it's going to start down, it's going to end down. So for instance, if I'm going to start up, it's got to go through what? And then it's got to go through. And then it's got to go through. And then it's got to go through. Yes, because you could go down too. I wouldn't just touch it because if you just touch, like say at 4, you're saying 4 occurs twice and it doesn't.
Oh, I see.
So that's why I had to cut through all of them.
Got it. Yeah.
All good. Again, you could go start down, end down too. Anybody want to ask any questions off this? I was hoping, but if not, I'm not going to approach it. Nothing? Okay, I have to do it. I have to. What if it's odd? Starts and ends in opposite directions. High to low, low to high. How do I know though? Okay, ready? Negative 2x to the 3rd, positive 2x to the 3rd. This will be high to low. And this will be low to high. And if you're ever unsure what's everyone going to have with them that day, calculator, you can just plug it in your y equals and say, oh, that's high to low to high. Okay? Questions there? All right. And okay, this next one I'm about to do before I get fired up, we got to get it right. It's going to be a 4-point question. Got to get all 4 points without a doubt. All right. It was not the greatest in our last unit, but if this comes up, we got to get it right. All right. This whole unusual or not unusual deal, significant or not significant. Okay. For number 35, it's 4 points. There's only one question that's worth more. Yeah, that's the big 6-pointer dog at the end. Who knows what that's going to be? Okay, I know it's a lot to read, but look, here's what it's asking. Based on the simulation, can we claim that the station averages 30 minutes plausible, or is it unusual? Okay. Explain your response with an interval that contains the middle 95. What are they asking for right off the bat? Confidence interval. Done. Here we go. Look it up if you need to. It's on those sheets. Oh, here we go. Confidence interval. Here you go, 11. Confidence interval.
Is that one plus or minus 2 standard deviation?
No, it is not.
Okay, that was low or mean plus or minus the margin of error.
All seriousness now. Where do I get the mean? It's on the simulation. It's on the simulation already. Make sure it's because, hey, you're using it based on the simulation. Don't use the mean up here. That's off the survey. This is the one we want right here. Based on the simulation, 29.101 plus or minus. New person now. How do I find the MO? The margin of error, 12? 2 times, where do I get the standard deviation? From the simulation. What is it? 0.934. And then you guys add and subtract it from the mean.
So why did they give us 2 different?
I don't know, because that's how the test goes. This, though, is from a survey.
Yeah.
So they surveyed 500 people. That was the mean, and that was the standard deviation. So now they did that, how many? 1,000 more times, and here's what the results they got. But the problem says based on the simulation, not the survey. And here's where a couple other people may lose a point now, at this point in the problem. They do this all the time. Drives me nuts. You see how your mean was 3 decimal numbers after the decimal? But what's the rounding directions? 100th. 2. Got to be aware of that. 2 points after. All right, what is my confidence interval? All right, here we go. 7, confidence interval.
27.23.
Yep.
To
30.97. What am I checking for? What's the number I'm checking to see if it's plausible? 30. Okay, look at that. You did the work already. Where's 30?
That's definitely possible.
30 is in between. Is it doable? Yes, it's not unusual. It's plausible. It's doable. So this is just yes because falls in the confidence interval. 4 points. Here you go. Done.
Oh yeah.
4 points. Find the interval, see if it fits in or not. Okay. All right. You guys are turning it over to you here this last 12 minutes. Please ask me questions. That was just the same one duplicated. There you go. Here we go. Please ask me questions as I come around and help you out. You guys know where the answer key and video solutions are? Hurry up, boss. Let's go. We gotta get